Hello, my dear children. Today we are going to discuss about algebra of real functions. In the exercise 2.3, in the chapter Relations and Functions, exercise 2.3. This is the last concept. Okay, my dear children. Algebra of real functions. First one, addition of two real functions. Let f is a mapping from x to r and g is a mapping from x to r be any two real functions. Okay, my dear children, f and g are two real functions. If you observe this domain of f and domain of g, both are equal, same. Okay, my dear children, and codomain also same, real numbers and set of real numbers, where x is a subset of real numbers. Here and as well as here also it is a subset of real numbers. Then we define f plus g. F plus g is a mapping from x to r by f plus g of x is equal to f of x plus g of x for all x belongs to x. So you have to remember this part only. Okay, my children, f plus g of x is equal to f of x plus g of x. This is the sum of the two real functions. Okay, my children, understood? Right. Now come to second one. Subtraction of a real function from another. Here we are defining subtraction of a real function from another. Let f is a mapping from x to r and g is a mapping from x to r be any two real functions. Okay, my children, here f and g are both are real functions. If you observe domain of f and domain of g, both are same. Okay, my dear children, and codomain of f, here codomain of g are also same. Any two real functions where x is subset of real numbers. Okay, my dear children, then we define f minus g is a mapping from x to r by f minus g of x is equal to f of x minus g of x for all x belongs to x. This is important step. Okay, my dear children, f minus g of x is equal to f of x minus g of x for all x belongs to x. Okay, my dear children, understood? Right. Now come to the next point, that is multiplication by a scalar. Here we are multiplying a function by a scalar. Let f is a mapping from x to r be a real function and alpha be a scalar. Scalar means constant. Okay, my dear children, here by scalar we mean a real number, especially alpha means a real number, constant, scalar. Then the product alpha f is a function from x to r defined by alpha f of x is equal to alpha into f of x for all x belongs to x. Remember this step, my dear children, this equation. Okay, my dear children, this is multiplication of a function by a scalar. Okay, my dear children, right. Now come to the next point, that is multiplication of two real functions. Here we are defining the multiplication of two real functions. Okay, my dear children, the product or multiplication of two real functions, f is a mapping from x to r and g is a mapping from x to r, is a function fg is a mapping from x to r defined by fg of x is equal to f of x into g of x. Remember this equation, my dear children, this is important. So fg of x is equal to f of x into g of x for all x belongs to x. This is also called point-wise multiplication. Understood this point, my dear children? Right. Now come to the last point, that is quotient of two real functions. Quotient of two real functions. Here we are defining quotient of two real functions. Let f and g be two real functions from x to r, where x is subset of r, set of real numbers. The quotient of f by g, denoted by f by g, is a function defined by f by g of x is equal to f of x by g of x, provided g of x is not equal to 0 for all x belongs to x. Understood this part, my dear children? This is important. F by g of x is equal to f of x by g of x. This is called quotient of two real functions. Okay, my dear children? Right. Now come to the exercise 2.3 sums. Concepts or points of exercise 2.3 are over. Now we are starting the exercise 2.3 sums. Are you ready to listen the class, my dear children? Right. See page number 44 in the textbook, page number 44. See the question number 1 in the exercise 2.3. Is set ordered pair 2, 1, ordered pair 5, 1, ordered pair 8, 1, ordered pair 11, 1, ordered pair 14, 1, ordered pair 17, 1. A function, it is a given relation. We have to check whether this relation is a function or not. Understood the question, my dear children? If it is a function, determine its domain and range. If this relation is a function, then we have to determine its domain and range. Understood the question, my dear children? So this question is based on the definition of a function and domain of a function and range of a function. So you have to recollect the previous knowledge of definition of a function, domain of a function and range of a function. If you don't know these definitions well, you can't answer correctly to this question. Okay, my dear children? Right. First come to the solution. First we write given relation as it is. I wrote the given relation as it is. It is easy to check whether the given relation is a function or not with the help of arrow diagram. So I have drawn arrow diagram. In this first set, I am writing the first elements or first components of every ordered pair. 2, I wrote here, 5, 8, 11, 14 and 17. I wrote all the first elements or first components of every ordered pair in the first set. Next, in the second set, we write all the second components or second elements in the ordered pairs. So here 1, here also 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 1. So only one element is there in the second set. Here 2 is related to 1, 3, 5 is related to 1, 8 is also related to 1, 11 is also related to 1, 14 also related to 1 and 17 is also related to 1. If you observe this arrow diagram, every element in this set, every element in the first set having a unique image, not more than one image. Image of 2 is 1, image of 5 is 1, image of 8 is 1, image of 11 is also 1, image of 14 also 1, 17 element image also 1. So every element in the first set has a unique image, means we are not drawing more than one arrow from every element of the first set. Understood this point, my dear children? Right. So it is clear from the adjacent arrow diagram that no two ordered pairs have the same first components. Means we have not drawn more than one arrow from every element of the first set. Understood this point, my children? Right. Hence, this relation is a function. Understood this point, my dear children? Right. Here, domain. You have to recollect the definition of domain. What is meant by definition of domain of a function? The set of first components or elements of ordered pairs. What are the first components or first elements of the ordered pairs in the given relation? 2, 5, 11, 14, 17. So this is the domain of the function. Understood this point, my dear children? Right. Now come to range. What is meant by range of a function? The set of all second elements or second components of the ordered pairs in the relation. So what are the second components or second elements in the ordered pairs? Only one element, that is 1. So singleton set 1. Understood this question, my dear children? Right. In this Roman, two more questions are there. You try them. If you have any doubt, ask your doubts and get your doubts clarified. Okay, my dear children, I am not explaining the remaining two in this Roman. You try them. Okay, my dear children? Right. Now come to the question number 2. In this Roman, there are two parts. First part, find the domain and range of the function f of x is equal to mod x. This is the given function. What should we find here? Domain and range of this function. Understood the question, my dear children? Right. What is meant by domain of a function? Domain of a function means the set of all x for which the function is defined, for which the function is a real number. Okay, my dear children. What is meant by range of a function? The set of all function values for given x values. Okay, my dear children. Right. So given f of x is equal to minus mod x. Now we are going to find domain. See here, minus mod x. Minus mod x belongs to R. For every x belongs to R. If you take any real number, then minus mod x is also a real number. So we can say that here f is defined for all x belongs to R. This function value must be a real number. Okay, my dear children. Whatever the values are given for x, then the function value must be a real number. So for every real number x, minus mod x is also a real number. Therefore, we can say that domain of f is equal to R. Understood this part, my dear children? Right. Now come to range. Range means this function values, this value. Now mod x is greater than or equal to 0 for all x belongs to R. If you take any real number, then modulus value is always greater than or equal to 0. You know this result, my dear children? Right. This implies if you take minus on both sides, if you multiply this inequation by minus 1, we get here minus mod x is less than or equal to 0 for all x belongs to R. What is meant by minus mod x here? Minus mod x means f of x. So f of x is less than or equal to 0 for all x belongs to R. It means the function values are less than or equal to 0 for all x belongs to R. Understood this line, my dear children? Right. So what is meant by range of a function? Range of a function means the set of all the values of the function, that is equal to minus infinity comma 0, left open, right closed. That is equal to set of all negative real numbers union singleton set 0. Understood this point, my dear children? Right. Before going to solve the second question in the Roman number 2, let us discuss this point, which is very useful to solve the second question in the Roman number 2. It means finding the range of a real functions, Again, let us define range of real functions. The range of real function is the set of all real values taken by f of x at the points in its domain. The set of all values of f of x is called range of a function. In order to find the range of a real function f of x, we may use the following algorithm. Here we use some steps to find the range of a real function. See this algorithm. Step 1. First step is put y is equal to f of x. This is the first step. Okay, my dear children? Right. Step 2. Solve the equation y is equal to f of x for x in terms of y. Let x is equal to phi of y. From this equation we have to write x as a subject. Means in LHS there should be only letter x should be there. All the remaining terms should be written in RHS. Understood this point, my dear children? Right. Step 3. Find the values of y for which the values of x obtained from x is equal to phi of y are real and in the domain of f. So from this equation we have to find the values of y for which the x values also must be real and it should be in the domain. Step 4. The set of values of y obtained in step 3 is the range of f. Okay, my dear children, we have found the values of y in this step. So that's in this step 3. So the set of all the values of y is the range of the given function f. Understood this point, my dear children? We follow these 4 steps while you are going to find the range of a real function. Remember these steps, my dear children. This is a very important algorithm. Okay, my dear children? Right.